Hello everyone and welcome to VEP, a show about videos, electronics and programming. I'm your host Panas and this is our first episode where we are going to explore electronics and science. Today we're going to build a simple but effective measuring device that will interpretate distances to your PC screens. We are going to learn about Arduino, programming, how ultrasonic sensors work, how to make a computer talk, generally communicate with the Arduino, and we're also going to explore some aspects of sound wave physics. What we're going to need for this project is a microcontroller. I like to use an Arduino Uno for such a simple project, like this that you see on your screen, an HC SR04 ultrasonic sensor. This is the kind with the 4 pins, a ground pin, a VCC pin, which is the voltage input pin, an echo pin, and a trigger pin. And for the software, we're going to need the Arduino IDE and also processing. Processing is a Java-based visual programming language. You'll find links or where to buy the hardware and download the software on the description down below. Now that we have all of our components, let's build a circuit. This is fairly easy. For the ground and VCC pins, we're going to use the ground pin shown in green and the digital pin 11 shown in red with the caption VCC. The connections we're going to make are as you see on your screen with the blue wires. But I'm getting too technical here. This is how to actually build a circuit. Well, before we move on with the programming of the Arduino, we need to understand how an ultrasonic sensor works. Basically, an ultrasonic sensor has 2 circular pieces. One is the trigger and the other one is the receiver. The trigger sends a sound wave for a very small time interval. Now it's about 10 microseconds. And once the sound wave finds an obstacle, it bounces back and gets picked up by the other circular component, which is the receiver. So what you get is the time needed for the sound wave to travel to the obstacle and back. This process happens many times per second. But we don't want time. We said that we're going to measure distance. So here's where physics come to play. We know that sound travels through air at a velocity of 343.2 meters per second. And we also know that sound travels at a constant speed. So the equation of the distance of an object in constant speed is distance equals velocity times the time. That will give us the distance in meters. But we want it in centimeters, so what we're going to do is just divide the outcome by 100. So that way we have distance equals velocity over 100 times the time. But we have to consider something here. The time we get from the sensor is the time required for the sound to travel from the sensor to the obstacle and back to the sensor. That's twice the time we need. So what we're going to do is just divide the time by 2, and as a result, the final formula for a distance is distance equals velocity over 100 times time over 2. Now that we've understood how an ultrasonic sensor works, we're going to write some code for the Arduino. You can find the code once again in the link in the description down below. But I'm not going to go in such detail on how to write the code. We're probably going to cover this in another episode, but I want to specify some parts. Firstly, because we are not connecting the sensor, the VCC sensor, directly to the 5-volt pin of the Arduino, and we're using pin 11, we have to say to the Arduino to output from pin 11 constantly 5 volts in order for a sensor to work. We're gonna use this typing a very simple command which is called digital write, And you can see it here, how its syntax and how it's written. Now we just have to connect the Arduino to the computer and open the serial monitor to view the result. As you can see, I've used a piece of foam core as an obstacle to investigate the distance, and to be honest, the sensor is pretty accurate. But now let's take this to the next level. We now want to view the results in a more fancy, let's say, way. This is where processing comes in. We're going to make a simple applet. An applet is an app, basically. The applet will take reading from the serial monitor and then create a rectangle in the screen exactly the same centimeters long as the distance of the sensor to the obstacle. From the sensor to the obstacle. Here I'd like to say that there are many ways to output the results you get from the sensor. You can use an LCD, or some blinking LEDs, or even some vibrating motors. But we decided to use this specific method. So this is the code that you will put on processing. I'm going to let you guess where to find it. Just a little reminder, on the Arduino code we'll need to remove the line that prints centimeter, the cm, the centimeters, to the serial monitors, because this will confuse a lot our processing applet. There you have it, a nice small digital measuring device that measures accurately certain distances. If you've tried any of these builds yourself, I'd love to see your creations. Put them on the comments below or on our Facebook page, and also I would really like to see some comments or advices, whatever you have, it's good. Until next time,